Hi folks, good morning. Hopefully the traffic wasn't too bad. That's what I hear is usually contributes to low energy in the morning. But anyway, let's get started. Talking about distributed databases should fix that definitely. So, um, okay, is anyone able to see? I see. Okay, it's one. I see it. Okay. So maybe in the meanwhile, let me quickly introduce myself. Like I'm Karthik. I'm one of the co-founders at Yugabyte DB, and mostly been in various technical roles before. I was at Nutanix and Facebook, and my co-founders and I and a bunch of people in our team. We just can't get enough of building databases, so we built Cassandra, HBase, now Yugabyte. We built one more inside Facebook, so you get the idea. Distributed databases are our passion, and here's to the next one, right? Like, so Yugabyte has been a pretty interesting journey. Once we are ready, I think we'll jump right in. This talk is about going from resilience, which most of you might know the word, is about how do you deal with failures, to ultra resilience, which is something that's more of a cloud native way, right? Like, so it's not just about explicitly when there are failures. While those are important to deal with, sometimes they're the simpler thing, and the things that get you are the various other things you have to do more often, more frequently, or not as cleanly as failures, and we'll talk about some of them. Okay. Okay, yeah, it's working. So Yugabyte DB, just a quick background and intro to people that haven't heard of it. We are a database. We are a distributed database built primarily for scalability, resilience and uptime, so high availability and replication of data built into the database. The main question we got right when we started building the database is, why the hell are you building another database? There are about 350 databases out there. Can't you pick one and improve it? It'll save everybody's effort, right? The real answer, though, when we drill down, is it's not the database that people were complaining about, it's the database API. So you build one more database and you say, look, this is the greatest database you've ever heard, and it's this, it does that, it does that. Okay, how do I use it? Okay, I'll teach you about a new API and a way to use it. Everybody walks away because nobody wants to learn that. It takes 6 to 8 years to learn a new database API. So our strategy here was the stuff in the black bold in the middle. We said we're not building a new database API. It's going to be exactly the same as databases that you already know. And the way we would describe it is exactly like that database, except here are the things that we're adding to it. And that's a lot simpler, and that resonated, and here we are off to the races. So Yugabyte DB has two APIs that it impersonates. One is the PostgreSQL API, and the other is Apache Cassandra. To Postgres, we add properties of scale, resilience, geodistribution. To Cassandra, we add properties of transactionality and document orientedness and all of the other features that people often ask us for, like secondary indexes and so on, right? And primarily, it's to enable building cloud-native applications in a cost-effective manner without compromising on anything, right? So the Postgres API, don't need to justify it. I used to remember a time 4, 5, 6 years ago when I'd say, Postgres is going to win, and I don't need to say that anymore. Everybody has heard of Postgres. It's topping all of the, the surveys and lists. Everybody's adopting Postgres everywhere. So, thank God we chose Postgres, and thank God Postgres became popular. Otherwise, I don't think I'll be speaking here about this stuff. But anyways, it's all good. We'll call it good. So, Postgres is open source. It's got a lot of capability. It's got a lot of features. People are adopting it to move quickly to build a lot of applications. And we wanted to, keep all of that the same, right? And so if you think about how you build a Postgres compatible database, Postgres is very complex, by the way. It's like 30 to 40 years of development in there. And we know from first-hand experience, because the first time we tried to emulate the Postgres API, we thought, like, how bad can it be? Let's just write it from scratch. And 6 months later, we're like, you know what, this is not going to work out. Let's put all the stuff we did away, and let's start with the Postgres code base and give it a lot more respect, and be serious about how to build it in a Postgres compatible way. That's because we wanted to achieve runtime compatibility, which means you write an application on Postgres, you move it to Yugabyte, it should run the same way, not like syntax, drivers, kinda, sorta, error codes, retry logic. Everything has to be increasingly the same, because no one wants to learn how to do XYZ, right? Like anything. And the more you have to think, the harder it gets, the more there are chances for mistakes, the less it's integrated with open source tooling, other ecosystems and frameworks and so on. Okay, so this is, I think, what we're super proud about in a database. It is that we have a distributed transactional storage layer. That's the middle thing, and it can run on any substrate. It has no external dependencies, so you can have a cluster where some nodes or compute instances are on a private cloud, multiple different public clouds. You can run it on Kubernetes. You can go from one to the other. All of these, and the layer above it exposes this through known APIs, right? So it's an extensible query processing layer, and the two query processing engines we have, one of them is the Postgres code, the Postgres query processing engine, and the other one is a ground-up built Cassandra query processing engine. It's all written in C++, so it's a new code base for the Cassandra side, and it reuses Postgres' C code, right? So we are able to bring most of the Postgres features, like including pretty advanced things like stored procedures and triggers and all of the advanced things. Everything just is there. We don't ask, is it useful or is it modern? We just say Postgres has figured it out, so we're just going to follow Postgres. Okay. So let's come back to our original topic, right? So this was Yugabyte, and what does this have to do with the topic here? So resilience. You guys know what resilience is. It's about how do you, adapt to a failure or a change or a disruption, right? It's simple. And this is something that, like I was saying in 2007, when I joined Facebook, one of the issues we had was we needed a database that was resilient, right? And that was not operationally hard. And we found there was nothing in the open source, and we had built this system which we eventually called Apache Cassandra, which we called Cassandra and open source through the Apache Software Foundation, and it just took off, right? It shows you how important resilient systems are. But if that was already there, then what are we talking about today, right? So resilience is no longer important. Cassandra was built, and so was HBase, and all of the NoSQLs, they were all built in the pre-cloud era, right, before the cloud was around. When cloud came up, a few things changed. You had zones and regions, you had multiple data centers, you had commodity hardware, you had noisy neighbor, you had VMs and virtualization, and you had flash disks. So I threw a whole bunch of stuff. You also had CI/CD and infrastructure as code and a whole bunch of other things come up. These are all buzzwords, but they're also real things, right? And so resilience is not enough. Okay, this is not updating again. Okay, yeah. So customers, if you think about it, want to build and run applications that always work, right? So if you build an application, if somebody builds an application and you're using it, I'm the same way, and it doesn't work, I'm like, oh man, this application sucks. Let me just switch to the other thing that works, right? And you'd go to a competitor in a heartbeat. That's all it takes. And there can be a very, very big story behind, why this was very hard to architect and develop, but all that matters is somebody else is making it work, and that's it. That's all it takes to lose a brand image, right, or following. Nations have started running on digital infrastructure. Like, India, for example, a lot of things are getting digitized very quickly, like payments, like a lot of other things, a lot of, national infrastructure going around. And brand is everything, right? Like if people don't trust, like, for example, let's say a service is down, and people are going to say, you know what, they're not able to keep the service up. What are they going to deal with my money, right? If it's and it may not be fair, it may not be even the real thing, but that's how brand perception works. And whether it's a Twitter or a Facebook, or whether it's a money moving application, or whether it's like a a transportation e-commerce application, everywhere people associate the uptime and the quality of the service to the brand and the reputation of what they do, even though it has nothing to do with whether they're able to run it well online or not. It is definitely becoming a very important signal in the world today. So what has changed is essentially these things. Going to the cloud, right, a cloud native way, decreases your cost, right? It decreases your cost because you are now moving from custom hardware to commodity hardware and VMs. You're going from dedicated hardware to shared hardware, like shared VMs. And the downside is there's more failures, right? Okay, so you get the cost, you decrease your cost, but you increase the probability of your failures, which you have to deal with. You also have more scale, so it's pay as you go or on demand, and you don't want to make it a giant cluster upfront without knowing that it's succeeding. You don't want the success, the virality of success, to come hard down bearing upon you, right? So I'll give you a very quick anecdote. Like I said, I joined Facebook back in 2007. And through 2007, 8, and 9, every week we used to have an internal meeting which said, this week the site is gone, we're down, it's going to be down. And Twitter was having the same thing. They were also struggling because of the growth, and they had this whale. I don't know how many of you remember the whale. Yeah, you guys remember the whale, the fail whale. That word came from there. So they used to draw this whale and say, sorry, we failed, we'll be back. Okay, they'd done it 4 or 5 times. It even made the news, right? Like, I mean, just 4 or 5 times, but it made the news. And we used to say internally, we better pick another animal very quickly because this is the week we will need it. And we kept saying this for every week. Okay, we said this for 1.5 years. We were investing in other stuff on the side, but until we were able to get to a resilient architecture that took care of all of this stuff, we were pretty much in the red zone of figuring out that animal that we had to put. Fortunately, it didn't happen. We got through this thing very quickly, but it just goes to show that ultra resilience was not enough. We were resilient. We could always throw. So was Twitter. They were resilient. It's fine. But that's not the point. The point is you have to wax and wane with the demand very, very quickly. And you have to be able to ride those ultra spikes very quickly and so on and so forth, right? So coming and talking about failures, it used to be that I'd have to say look, failures really happen. Don't think it doesn't happen. Now everybody hears all over the news something or the other fails. What happened to the brand? 20% of internet traffic dropped. This, that, all of that stuff does happen, and there are very real reasons. It's not that people are very negligent and doing their jobs. They do have the best of services, but things happen, right? Like natural incidents happen. Act of God, like unforeseen circumstances. It does happen, right? So this is a real thing. And major outages are, not uncommon, and minor outages are very common on a daily or weekly basis. They happen all the time. Like a 10-second network partition, I mean, if you're going to chase those down, that's like a lifetime, like that's all we're going to be doing 24/7 in the public cloud. Noisy neighbor, you have to figure out how to architect around these things, and that's where the strength of the infrastructure comes. It is about exposing reliable on top while working on unreliable underneath. That's every layer of infrastructure, and that's the way we have to think about it, right? So on the data side, these are some of the common types of failures, right? Again, common infrastructure failures. My node went down, my VM went down, my whatever went down. Let's call it in-region resilience. What do you do inside a region? To my entire region went down, the power grid went out, like there was an earthquake or a storm or some fire hit some building and then things went out. So that is business continuity and disaster recovery. How do you handle those BCDR, multi-region? To somebody connected to they were doing some work and they dropped this table because they were, on a development machine, and then it turned out that was actually production and not development, and now that table got dropped, and now, oh shit, what do you do? How do you get that table back, right? I mean, you're laughing, I'm sure this is a laugh because everybody has been in that situation. It's not laughter at who would do that. So anyway, yeah, I can also tell you it's the same on my side. I'd laugh with you guys. So same thing, data protection is super important. With all of these copies, if you intentionally drop the data, even though it was accidental, well, too bad, all the copies are gone, and now you need to figure out what to do about it. Okay, and it even happened recently, I think in the news, somewhere somebody deleted all the accounts across and so on, right? So and things like, for example, security patching, Heartbleed, all of these things do happen, and then it becomes a fire drill. And if you have 50 services, it becomes a really big scale fire drill. And if it happens 5 times, well, good luck, 50 people are quitting because everybody is bored of patching this stuff in a fire drill. Too much pressure. I had a very funny incident once. They said that they migrated from database A to a distributed data, I think Cassandra or something, database B, and these guys worked really hard, this team, through Christmas through New Year. Very hard, figuring out how to move this data, this, that, getting all this tested, everything, and so tired at the end that they dropped the new database by mistake. Okay, so life sucks, but yeah, so be it. So anyway, so things like these type of operations have to be API made into APIs and bulletproof and so on. And there are the worst kind of failures. I'll tell you is the 5th one on the list. It's very conveniently hidden at number 5. It's these intermittent failures where things don't fail and things don't work, and they're in the middle. And it kind of works and it kind of doesn't work, and people are unhappy, but you can't figure out what's going on. It's like, dude, it seems to be fine. And then they're like, you have to do something about it. Should I make it stricter? Yeah, make it stricter. And then it keeps throwing alerts, and then the ops guy is like, dude, you have 50,000 alerts. What do I do with it, man? What would you do if you are in my situation? You get 50,000 alerts. So he said, no, let's go back, and that type of stuff, And lastly, the spikes, right? Yeah, we'll talk about it. I'll give you an example. So, okay. So the clock is ticking, so let me go quickly. These are the 6, right, that matter. And this is really from talking to a variety of builders and people running services, not just on us, right, cloud native services. This is including, like cloud native, born in the cloud companies like Facebook, like Google, like a lot of them do focus on these principles when they're trying to bring their applications and services into the cloud, or build it for the cloud. So let's dive very quickly into these 6. So the first one is in-region resilience. So the most important takeaway, right? Like, I think everybody understands what this is. Hopefully everybody understands what this is. Let me know if you guys don't, and maybe we'll talk offline. But components fail inside a region. Nothing new here, right? But why is this important, right? It is important to innovate here because the way we used to do things before, right? When you had a couple of databases and that was like inside a data center, and you had a couple of data centers, things wouldn't fail. It was the pets versus cattle analogy, very crude analogy, right? But anyway, the analogy is, if it's a pet, right, and you have a pet, you will name it and you will bathe it every day and groom it and you'll take real care of it, right? And if it's cattle, like if it's in a cattle farm, you're not going to name every cattle and bathe it. As much as you want to, there's too many cattle there, right? If you're doing it as a business. So as cattle, you have to be able to treat it in a more black box manner. As pets, you will give it tender love and care. When you have 1 or 2 databases, they are pets. When you have a lot of services, they start to become cattle. When they go to the cloud, they definitely become cattle because you don't know which VM, whatever. So it just has to be business and just operate it as a business. So the main takeaway is that in-region resilience used to use DR techniques in the previous, when they are pets. It's okay to do the full fire drill if there's even like a network partition. That's okay, man. It's like a pet. You're like, you want to spend time with it anyway. What's the big deal, right? But if you have so many pets that they become cattle, you're like, I'm just tired of dealing with this, right? So people who have, I think, a lot of kids, they'll understand, right? Like but anyway, I'm just kidding. So, or maybe it's just me. But anyway, so what could go wrong? You could have a lot of these failures, right? And that makes your day job really sucky, and you don't like databases anymore, or any component for that matter, because all day long you're pushing this button, getting that running, getting this thing done, all of that stuff. It could be transient failures. Before you can react, it's gone. 5 people are angry with you. You don't know what to do, and you're trying to explain to this guy, no, this is how it works, and nobody wants to listen to you. And it may or may not heal automatically. You may have to go in there. You may get woken up at 3 a.m. And by the way, I can tell you this, when we built databases at Facebook, they had a you run what you build policy. Probably meant it for the app guys, but they made the database guys do it too. And I can tell you that the number of times we were woken up at 3 a.m., it taught us very quickly what not to do. It's like, you're building that feature. No, you can't build this feature. This feature, not this also. No, not this also. So you just know what not to put in because you just don't want to deal with those 3 a.m. calls. And the people that are dealing with it, like, it is painful, right? And so you have to have an automatic way so you can come at 10 a.m. and deal with it, not at 3 a.m. in the morning. Okay, so let's keep going. An architectural change, at least from the database point of view, solves this naturally, right? So that's what distributed SQL does. Raft consensus, replication, highly available with zero data loss. These are type of the characteristics that you want in a system that can automatically deal with transient or permanent failures inside a region, right? What you want to do is do that extra work so you don't have to use the heavy hammer DR technique when you really like databases. You can use a lighter weight technique so that you can push most of this burden to the system. So you don't want to compromise on how much data did I lose, can I rebuild it, and all of this stuff every time a blip happens in a region, because they happen way too frequently, right? So that's really the takeaway here. And the other key thing is, you don't want on the application side to be aware of where is the primary and where is the secondary or the replica, and oh wait, the primary is doing all the work, replica is sitting idle, that is burning cost. Let me figure out how to push more reads to the replica so its CPU also goes up, and I don't have any reads to put some reads, man. At least everybody will feel good that the CPU usage is not like 5%, it's like 50%. You don't need to do these kind of things. You can simply write to any machine, it will work. You can add machines, remove machines, change machines. All of this stuff just works naturally. This is the power of building it into the architecture as opposed to handling it outside. Okay, second of the elements is BCDR, business continuity DR. Fancy word to say if your region goes out, what would you do? You need to have a plan B, right? So, so what you want here is that, so DR, when an entire region goes out, people are more likely to, consumers are more likely to forgive you, right? Yeah, it works, the latency is a little high, but man, that entire region went out, that is tough. This is really good. These guys are doing really good. So there is that. And there is another aspect to it where you're like, dude, region goes out or not, I don't want to be bothered. I just want this thing to work because it is so critical for me. You see both flavors. It depends on the application. It depends on the business. For example, a retailer might say, I want my shopping cart ad online to succeed. I don't care if the region goes out. It's about me. It's not about others. I need it to work all the time, because if that thing goes down, yeah, everybody will be sympathetic, but I'm not making the money, and that's important for me. Whereas somebody else in the money moving business might say like, you know what, I cannot deal with things getting very slow or something. I'm okay if I'm like, I have to go and inspect it and do a certain other thing, or like your throughput is so high that you're willing to make some trade-offs. So it's about trade-offs, like we talk about on the right. It's about performance, your latency, and your throughput, as well as your recovery time. Is it automatic? Is it manual? And how much of data loss can you survive? And how do you want to architect it for the other aspects, like your steady state latency, how close the data is to your users, and all of that stuff. So there is a DR architecture. With Yugabyte DB, one of the things that we learned at the HBase time, like very, very funny incident also. So we had 100 plus petabyte clusters, right? We had hundreds of petabytes. Each cluster would have a few petabytes. That would be the size of a single cluster, and there were like tens of these clusters. So we had 100 like few petabytes in a cluster sitting here. People are running messages. This is like a Facebook Messenger, and this is competing with the carrier. So it is actually being used in semi-critical systems. So we cannot keep downtime there. Somebody uploaded, like something wrong happened with the network configuration for the outbound switch, that 1 in 10 packets would get dropped. Okay, if the damn thing just failed, it would be a lot simpler. And if it worked, that's fine. If 1 in 10 packets gets dropped, every now and then your latencies are spiking, but it's not so rare that nobody complains. It's pretty frequent that everybody is complaining, but what do you do? And we had a DR system on the other side, and we were like, should we flip the switch to the DR system and lose a little bit of data, which is like, will be a few terabytes when your flow is like hundreds of terabytes per second? Or should we just wait this out because this thing will get fixed soon? Right? It becomes a tough emotional call. So those are the times when we learned that you need both options. You need to be able to understand what your service needs, and they change over time. So these are a couple of options here. Like on the left, on that side, farther away from me, is a stretch cluster or a global database where you can have synchronous consistency, and on the right is where you can do asynchronous replication across two multi-zone deployments across two regions, right? So they give you different characteristics in terms of failures, and you can do fancier things. You can do things like, I have a single zone in the middle with async replication to a faraway region and read replicas in 3 other regions, and I can only do replication factor of 2 in these 3 regions. So now you're probably thinking like, yeah, what the hell, is all very great, is PowerPoint slides, awesome, right? But that is actually a real deployment that Airbolex which actually does, right? These guys are a global payments and financial operations platform, and that fancy stuff which looked like just some theoretical distributed systems thing architecture is indeed what they deploy, because they do have cross-border payments, and they do have data that has to move closer to users, and so on and so forth, right? So this is starting to happen. So let me go on to the other couple of things. Data protection is about, like we talked about that accidental table drop, that kind of scenario, or even worse, like all kinds of things happen, and these things do happen when you're moving fast. Like you're rolling all your updates, your software updates and new features through a CI/CD, goes right through the CI/CD, hits a corner case, corrupts all the data. What do you do? Right, you should be able to go back an hour or 15 minutes or 2 hours or whatever it is, and pretty quickly, and start from there, and go ahead with the rest of the processing and undo the corruption reasonably quickly, right? So these are the type of things which no amount of replication, other things will help you. It has to be built in, and it has to have ease of use, and the most important thing is it works when you need it, and you're not doing an emergency fire drill trying to figure this out. Oh my God, get this piece from there, do something there, and like I said, drop the wrong database, and now you're like, oh my God, now you have to start all over again, right? So that type of a stuff. Yeah, there's more details here. Like there's also, when you get to the cloud, there's also a deliberate architecture which lets you increase throughput and performance. It has to be very deliberately thought through. What is the amount of parallelism you need? What is the number of buckets you would choose? How would you move data from your store to the backup, from the backup to your store? Would you copy 3 times from the bucket, or would you copy once from the bucket and then replicate 3 ways? There's all of these kind of details that start to matter. So it's not just about the ability to do this, it's the ability to do it fast. And like I said, we are now moving very quickly in the world of data from pets to cattle, because everything is becoming data driven. Everything has to have a new service or one more feature or one more API or something, right? And so these things become super critical as building blocks. Okay. This is an example of a fintech company, Xignite. They do market data, and they use a lot of these kind of recovery techniques in order to, along with a bunch of other stuff, right? So this is one of the reasons that challenges that they were facing. Okay, let's talk about zero downtime operations. This is the other one. Everything's great. You can handle all the failures. You can handle all of that. When you drop that table, you can get it back in a jiffy. But if you cannot do the routine stuff, like, what do you do when you have to upgrade software? What do you do when you have to patch the OS, right? Like when there's a vulnerability and you have to go and actually take it down. Many enterprises have automated this to say, no more arguing about do you need this patch or not. Every 30 days the OS is going to get patched and refreshed automatically, and there's no question. If you do it in the cloud, the fancy term is AMI refresh. If you do it on premise or in your own fleet, it's called OS patching. But anyway, AMI refresh or OS patching, what do? You don't want lots of data to move back and forth. You have to take this downtime. You don't want your application to get affected. This is becoming one of the database as a service building blocks, as managed service building blocks. How do you build this into the database architecture so you don't have to do a fire drill? Like I said, think cattle, not pets. You have to do this for many times over and over and over, right? And things like that. Instance types, we're a company that has been around for 8 years, so not really that long in the grand scheme of things, right? And we have changed like 4 times instance types on AWS alone. So it went from C2 to C3 to C4 to C5 to C5i to C7g to, it just keeps going, Graviton to, it just goes so many of these instance types that we have seen, and that's the same for everybody, right? So when a new instance types comes up, it is actually real savings in your cost, in your total ROI, right? And so somebody has to go and change the database to run from old instance to new instance, right? And probably is not the most attractive of jobs that everyone's saying, oh yeah, give me that job. I'd really like to take that task. That's my next project, right? It's like, okay, fine. At the end of it, if you don't screw up, okay, you don't get yelled at, right? So that's kind of life there. And so building that into the architecture is actually, useful. So anyway, so on and so forth. So, in all of these, you want minimal disruption. You want to do these operations frequently. So suddenly when they say, look, I have an emergency request, can you do another OS patch or can you change this machine type quickly? You should be able to handle it. It's not like, well, what do you mean? I just finished it last week. You want me to do it again? Like, I'm fine, go hire somebody else. You don't want to do that, right? So, and, ability to automate. So not only know when it starts, know is it happening, what is the progress level, when is it done, all of that stuff, right? And good observability, smart alerting, and don't keep alerting me when that machine is going down because I took it down to patch it. Just, things like that. Everything is becoming more automated. So, there are, people that looked for this type of stuff, like in specifically as the need in order to adopt something like Yugabyte DB. But anyway, the takeaway here is that, do think about these things as you are opting for your data tier. I have I'm going to finish the last two in a couple of minutes and have a surprise speaker. But anyway, gray failures, right? Like this is the one that I told you, if you remembered and were paying attention before, the worst kind of failures. These are the ones where it's called flakiness. It didn't happen on my machine. Only the QA guy found it, or any of these kind of issues. They fall here, right? These are intermittent. The repro is actually harder than the fix. It could be a one-line fix. It could not even be related to your thing. It's just something you have to tell people. Oh yeah, you need to allocate more IOPS, or maybe you need the cloud to not have. You need a better instance type with better networking in order to get through it, or whatever it is, right? Like, so there are a variety of different reasons this can happen. It may not even be related to the software, but being able to detect and handle this is a super critical piece of the overall infrastructure. Like I said, think it's reliability above but built on unreliable below. And if each layer thinks that way, then you'll get pretty good reliability all the way at the top. So we do see a lot of these. They are subtle to diagnose. They are very hard, and we have to deal with them one at a time. And we spend enormous time and effort and energy in figuring these out and putting it into our managed service software to be able to figure out these issues on public clouds. It's not that if you find it on AWS, now you can go fix it on GCP and Azure or whatever, because they exhibit different kinds of gray failures, not the same things. So it is a pretty tedious and painful thing. Right, so this is one that we have seen in a couple of customer environments where there's a gray out where you have EBS that's loaded on multiple things, and you'll have an EBS gray out. It's not a blackout, it's not out, it's in, but certain operations will fail, certain operations will take high latency, and these are things that we had to explicitly test, detect, find, handle, and so on, right? And this is one example, but there are many such examples. Okay. And last but not the least are peak and freak events. So unexpected bursts, DDoS attacks actually, and so this is another interesting one. So let me go through one real example of peak scale. So this is Paramount Plus. In the in the US, I mean, I think you guys might have heard of Paramount Plus. They're a streaming company, right? Like they have a lot of shows. They have online like things that they stream. They stream a very popular event in the US, like called football, and it's not played with the foot. It's American football, so it's the one where it's one of the top sports in the U.S. So the finals of the American football is called the Super Bowl, and we just went through this year. We were the database, which was the authentication and identity database for Paramount Plus. So if you bought a subscription, you would log in, and it would check with the Yugabyte database. Who are you? Have you bought the service? Are you allowed to see the stream? And they were the exclusive streaming. They had the exclusive streaming rights for the Super Bowl, the final, right? So everybody logged in. Now, the problem with being one of the pieces of infrastructure for this is that the 2 hours leading up to the event is insane hell. Everybody's biting their nails and sitting around and like, oh shit, is it going to fail? And it's like all this kind of stuff going on, because the number of people that log in or check that they can access the stream goes through a roof. So it's like a tidal wave, one-off tidal wave, right? Huge. And then if the game is going really well, more people log on. If the game is not going so well, people drop off. And then at halftime, there are very good ads, really funny ads. People put some of the most creative juices into these ads. Everybody is logging on. There's a different crowd to see the ads. And then after halftime, there's one of these singing shows, Taylor Swift show. So a different crowd is logging on for the Taylor Swift show. And then depending on how the game is going for the last 15 minutes, everybody is logging on to see. So through this event, pretty much if you're not like, you pretty much have had 2 heart attacks if you're like sitting in that place and trying to deal with this. So and they had to pre-scale this hardware, like this cluster, to some huge amount, 2 to 3x bigger to handle this wave. And in the middle of all this, like this is all not enough in itself. There are other characters trying to run DDoS to take the service down, because they're like, hey, why not, man? I don't have anything else to do, so let me go take the service down. So now they're making thousands of requests, and you'll have to deal with the fallout from that as well, right? So there's a whole bunch of complexity behind the scenes, and these are like, we're calling them peak and freak events, but they're pretty damn common events if you're a successful service, and you will have your natural peaks and freaks. So they had a multi-cloud deployment, multi-region deployment. They wanted people to be able to log in quickly and get access to the stream. No one wants to wait for minutes and that spinner and like, what is this service, and let me switch it to somebody else. You don't want all of that, right? So, and they do a lot of such events. They do, for example, Champions League if you're into soccer, and Big Brother and AFCs and a lot of other events, Grammys and a whole bunch of other events. So each one of this is its own peak and freak event. So if you have enough peak and freak event, well, guess what? It's no longer a peak or freak event. It's just business as usual, and that's what it is for a lot of these digital businesses, right? So digital services. Okay, so this, I have talked through most of this, so I'm going to skip this, but in 2021, and this is one of the reasons why they started looking, this is very fascinating. I mean, ask me offline, I'll tell you, but this was because of a limitation in their existing infrastructure where for a period of 8 to 10 minutes, nobody that paid for the service could actually authenticate, log in, and get access to the stream, right? And that kind of pisses people off, right? And when that pisses people off, you see tweets like this, and you'll have to then deal with the fallout. And like I said, it's also about the brand and the reputation of the brand, right? So, but it's great to see that these guys they took a lot of efforts. I can tell you this is an A+ team on the Paramount side, but it is the right infrastructure for the job, and this is how online events and services are moving. Now, there's a lot of people that come to me and say, really, I don't think I need any of that stuff. What I need runs on one node. Well, these are real workloads. I think all of this is actually just one workload, but there are enough workloads that have more scale than you would imagine is needed. So we have people doing over 2 million transactions per second, and with hundreds of terabytes of online data, and with a pretty large cluster. So scale, the most important thing is to be able to do it in an online manner. Like you don't have to, vertical, horizontal, doesn't matter. You just have to have your application running and you can scale. Okay, that's the most important thing. So in short, remember these 6 elements, like ultra resilience, not just resilience, which is probably one in there and not more than that. And the net takeaway that you want from here is, scalability, super critical, exactly when you need it. If you don't have it, that's when you'll fail. Because you succeeded, you'll fail, because people need scale after you succeed. Zero downtime, because the user doesn't care what happens behind the scenes. The show must go on. And cost, right? You don't want to pay a whole lot in order to achieve this stuff. So this is the net takeaway. If you can't remember 6, remember 3. That's maybe half the number. But I want to call Chetan. Like, are you around, Chetan? Yeah, hey, come on over. And he's from Navi, so instead of me talking about all this, I think maybe Chetan, you can talk about what you think are critical characteristics of a service. Yeah.
Hey. Hello everyone, I'm Chetan. I'm the lead software engineer at Navi. So at Navi, we are building financial products, things like personal loans, home loans, insurances, and all of this mostly goes through payments, and payments is critical. And we have started leveraging Yugabyte for our data storage needs. One of the key reasons why we have gone with Yugabyte is, I think, as Karthik mentioned, for resilience and for scale. So we would want to achieve scalability in a manner which is cost effective. And I think since it's a payment application, we have recently launched UPI as well. And we see a surge of traffic with our UPI applications. And we do not want a situation where a person who's doing a real-time payment goes through blips due to some of our database downtimes, right? So this is where Yugabyte has been really great in terms of the resiliency at scale. I think that's all I would like to speak.
Awesome. Thank you. Thanks, Chetan. Thank you. Yeah. Thanks. And I think yeah, that was it. So thank you guys.